equation are my answers to both of these equations. Okay. Now we can graph this. So in order to graph this, what we need to do first is to put these in slope-intercept form. That's going to be the easiest way for us to graph these. So the first one, I have 3x plus 2y equals 8. So I'll subtract 3x from both sides. And I have 2y equals negative 3x plus 8. Divide everything by 2. And for my first equation, I have y equals negative 3 over 2x plus 4. So I'll come over here and graph this. I'll do this in red. It should be a little bit easier to see because I have black down here at the bottom of my screen. But I'll come up here and I will make a point at my y-intercept, which is positive 4. Then my slope, remember, is rise over run. So rise over run. So I'll go down 1, 2, 3. I'll go right 1, 2. So I'm right here. Go down 1, 2, 3. Right 1, 2. And now I can make my line. Excuse me, getting a little bit sick here. There's the first one. So that's how we find the first one. So I'm going to come over here, come up here actually, and do x plus 2y equals negative 8. So subtract x from both sides. We should be pretty good at doing this by now. We've been doing this a lot here lately. So I have negative x minus 8, divide everything by 2. And I have y equals negative 1 half x minus 4. Remember, there's an imaginary 1 that we put right there in front of that, so that's how we get our 1/2. So that's how we get the 1/2. We'll make this 4 a little bit neater. Okay, so now I'm going to go over here and plot this at negative 4. So there's my y-intercept. And I go down 1, right 2. Down 1, right 2. Obviously, I'm having trouble counting these as well. So I'll go down 1, right 2. Down 1, right 2. Down 1, right 2. Go up 1, left 2. So here's my other line. Okay, what do you notice about these two lines? What's going to happen? Well, if I were to continue down my slope on the red line, so let me continue that down. So 1, 2, 3, right, 1, 2. 1, 2, 3, right, 1, 2. So if I continue this guy down, he's going to go through here, which means that these lines are going to intersect at this point right here. This big red point here with a little bit of blue right there. That point is where they intersect. If you remember from the slide before, we found that x equals 8 and y equals negative 8. Well, ladies and gentlemen, guess what that is? 8, negative 8 is this point right here where the two lines intersect. Pretty awesome, huh? Okay, now we're going to put this in a real-world application. So if the growth rates stay the same, what age would a spiny dogfish and a Greenland shark be the same length? That Greenland shark is very ugly. I don't know where, I would assume it's in Greenland, but yeah, that shark's ugly. Anyway, so we need to set up a system of equations. So I'll start here with the green. So I'll start with the Greenland shark. So I'm going to start with this guy. So if I start with him, let me make this a little bit smaller. I want to make sure that I have plenty of room here to work. So I know I'm going to have y equals. So y. Let's say that x is the growth rate. So x, let's say that x is the growth rate. If x is the growth rate, then I know I'm going to have 0.75x. So if that is the growth rate, so how much it grows in, what does it say, centimeters per So x is the growth rate, and that's centimeters per year, and y will be the length in centimeters. So x is how old it is, and y will be the length in centimeters. So that means that I have, it grows by 3/4 of a centimeter per year, and it started at 37 centimeters. So that means I would just add 37. If we come over here to the spiny dogfish shark, we have y. So the length of the shark is 1.5x plus 22. And what do we have here? We have a system of equations. So I'm going to do the same type of solution I did the last time. I'm going to do elimination. So I'm going to multiply the top here by -1. The reason that I can multiply the top by -1, if this is going to be a negative y, we'll get rid of our y's. So we'll get rid of the y's. And it's asking us to find the age. So here, it's asking us for the age. So if we can solve for x, that's going to tell us how old it is when they're both the same. They're both the same length. So I'll multiply this by -1. So I have negative y equals negative 0.75 x minus 37. So from here I can solve this. So I have 0 equals 0.75 x minus 15. So I'm going to bring this up here. So I have 0 equals 0.75 x minus 15. Okay, from here now, I'm going to add 15 to both sides. So add 15. So I have 15 equals 0.75x. I hate working with decimals. It's just one thing that I just don't really like to do. So what I'm going to do instead is I'm going to change that 0.75 into a fraction. So 0.75 is 75 over 100. Divide the top and bottom by 25. You'll get 3/4x. Okay, this is a big skill we've been working on in class here the last couple days. In order to get rid of 3/4, we have to multiply by the, yes, you guessed it, reciprocal. So we'll multiply both of these by the reciprocal. So these are canceled out. So I have x equals something. So I'm going to come down here in this little corner, and we're going to do this. So I have 4/3 times 15. Well, that's the same as 15 over 1. I could multiply across and get 60 over 3. Divide that, we'll get 20. So my answer here is 20. What I could also do here, down here in the red box, is I could say, okay, well, 3 divided by 15. So 3 divided by 3 is 1. 3 divided by 15 is 5. And I would get 20 over 1. So you see you're going to get the same answer. So we get the same answer no matter what. But still, I think this way in blue is a little bit easier. But we have 20 equals x. So what does that mean? If we had to put that in context, we would say that the spiny dogfish and the Greenland shark would be the same length when they are both 20 years old. Alright, and these are types of systems, so make sure you write these down in your notes. You should have been writing most of this stuff down anyway, but make sure you're writing this one down especially. So the intersecting lines. So right here, the first one on the left, so this one, intersecting lines. It has one solution. It has one solution if you have a system of equations and they are coinciding lines, like in here. Coinciding means that we have one line on top of another. So that means that we will have infinitely many solutions, because on top of the purple line, it's like our other equation would be, can't really see that very well, maybe the blue line. So they lie right on top of each other. So that means everything will be a solution. If we have parallel lines, the lines never intersect, so we never get the point that we were looking for in the first example, which then means we will have no solutions. These lines, these parallel lines, will never cross. Okay, now we're going to name these without graphing. So we're going to have to name what kind of solution we'll get. If they're going to be... Alright, so I'm going to put this in slope-intercept form. Both of these, it's going to be easier. We'll be able to tell based off the slopes and the y-intercepts. So if I put this first one here in slope-intercept form, I will have 4y. Oops, let me get my pen. Here we go. 4y equals 2x plus 6. Divide both by 4. Divide both by 4. I'll have y equals 1/2. that's the first equation. The second equation, I will have y equals 1/2 x minus, I'll have 12 over 8, which simplifies 2. Divide both of those by 2, you'll have 6 over 4. Divided by 2 again, you'll have 3 over 2. So if we look here, if the slope in our first equation, so the slope here, 1, so all that is 1 and 2. And this is problem number 1. So I'll even put this here. So my slope in the first one is 1/2. Slope in the second one. So the slope, let me erase that, make it easier to see. My slope in the second one is 1/2. If two equations have the same slope, that means they are parallel. So these will be parallel, that means no solution. So these, number 1, will be parallel. So make this in blue. So, alright, if we do number 2 now, we will have, put these in slope-intercept form. It's just a lot of switching around. So I'm going to have for my first equation here in number 2, I'm going to have y equals 3x plus 4. My second equation, let me do this really quick, and I'll just write it down so you don't have to, you guys should be able to switch now back and forth. So I have negative 1/3 y equals negative x plus 1. So I got to multiply by the reciprocal, so negative 3 over 1. So basically I'm multiplying everything by negative 3. So I have y equals, I'm going to have positive 3x minus 3. So number 2, once again, if we look at the slopes here on number 2, so if we look at the slopes, here, so I have 3x and 3x, the slopes are the same. They have different y-intercepts, which means they will be parallel. And finally, number 3, I'd like you guys to pause this and try number 3 on your own. And so finally, for our third example, I'm going to do it over here on this next slide. There's a couple different ways we could do these. I like putting mine in slope-intercept form. It just makes it a little bit easier to distinguish what my slope-intercept, because I don't have to solve for x and solve for y and then think, what does this mean? So what I'm going to do is I'm going to keep, I'll actually solve this one. So if I actually solve this, I'm going to multiply the top by negative 2. The reason I'm going to do this is to eliminate, my x's. So I'll have negative 4x minus 6y equals negative 2. X's are gone. I have negative 5y equals negative 5. Divide by negative 5 on each side, and I have y equals 1. So I'll plug that in here to my my second equation. So I'll have 4x plus 1 equals negative 3. Subtract 1, subtract 1. So now I have 4x equals negative 4. Divide by 4, divide by 4. X equals negative 1. So I got a point. Pretty cool. But let's see, so I got one solution. Let's see if this is a one solution and independent system of equations. Okay, now I'm going to put this in slope-intercept form to see if we get the same result. So I'm going to subtract 2x from both sides. Oh, whoops, excuse me, I'm going over to the other side. So, right here we subtract 2x. And get rid of these, so I have 3y equals, I don't like the way that looks, ladies and gentlemen, so I'm going to come over here. Okay, sorry about that, equals negative 2x plus 1. Divide each of these by 3, divided by 3. Y equals negative 2/3 x plus 1/3. Okay, that's cool. Come over here, now I'll subtract 4x from both sides, so that did come in handy. And I will have y equals negative 4x minus 3. Oh, cool, now we're done. If I look over here, my slope is negative 2/3. And my slope over here is negative 4. So